Okay, so a geometric proof or a proof is a convincing argument that uses deductive reasoning. It logically shows why a conjecture is true. A two-column proof is what we're going to be working on. And that's going to list a statement on the left and the justification or the reason for each statement on the right. So, proving segment relationships. This is your two-column proof. And at the top here, you're going to usually be given a picture. And in this case, it's a picture of a line, and then there are segments within the line. And they tell you that points P, Q, and S are collinear. We're trying to prove that PQ here is equal to the whole length of PS minus this QS here. So starting with our proof, when you're doing a reason, when you're putting a reason in, all you're doing is basically saying why you're allowed to do that. So you're going to be using a lot of definitions. So the first one, P, Q, and S are collinear. Well, that was given to us. That's right here. So that's always going to be our given. Then it says that PS is equal to, so the whole length here is equal to this little guy, PQ, plus this little guy, QS. And if you made your flashcards, you would know that that is the segment addition postulate. The segment addition postulate, if I put numbers here, maybe it'll help you. But the segment addition postulate says that part of a segment PQ, so 5, plus the other part of the segment QS, 10, equals the whole length of the segment PS, which is 15. So if I add 5 to 10, I get the whole length of the segment 15. That's just the segment addition postulate in letters. Okay, so now I have PS minus QS is equal to PQ. Well, what they've done here is they've mixed one of our algebraic properties. They're subtracting QS from both sides. So the QS goes away on this side, and the PS minus the QS stays as it is on this side. So all we've done is we've subtracted. Remember, that's your property of equality. Okay? And then from this statement to this statement, we virtually have the same exact thing. PS minus QS equals PQ, and PQ equals PS minus QS. So what they've done, and I'm going to write it down here, PS minus QS equals PQ, then PQ equals PS minus QS. So all they've done here, if you remember, if you fold down the middle here, this would fall on top of this would fall on top of this, and this would fall on top of this. They've just flipped our sentence around. So that's the symmetric property. And we just have to check to make sure that PQ does in fact equal PS minus QS. Okay, for the next one, we have DW, and I'm just going to mark DW here is congruent to ON. So those are congruent. And we're trying to prove that DO is equal to WN, or equal, sorry, not congruent. So DW equals ON, that's always our given. And then it says that DW, the whole length of DW here, is equal to DO plus OW. Well, once again, all we're doing is we're taking a little part of the segment, a little part of the other segment, giving us the whole segment DW. That's our segment addition postulate. And it says ON, well, it's in the same box as the segment addition postulate. So what we're going to have to do is finish up the segment addition postulate as it applies to ON. ON, the whole length of ON, is made up of OW plus WN. Okay? Now this next one is really hard to see, so pay attention. You're going to see it very, very often, so just make sure that you're looking for these patterns. All right, down here we have DO plus OW. Well, what does that equal? Well, we said, let's look up here, we said that dW equals dO plus OW, and ON equals OW plus WN. And up here, we had said that dW was the same thing as ON. So what I'm going to do is I'm going to replace this dW here with what we said it equaled down here. We said it equaled dO plus OW, right? And I'm going to replace this ON here with what we said it equaled here, which was OW plus WN. So that is the substitution property. So now I'm just replacing dO plus OW, we said it was here, equals OW plus WN. Now in the next step, OW is gone, and OW is gone again from both sides of the equation. Well, how do you get rid of something on both sides of the equation? So OW plus WN, I'm going to subtract OW on both sides of my equation, and I'll be left with dO equals WN. Okay, so now I want you to try this one on your own. See what you can come up with. This one is going to be extremely similar to the one we just did. Okay, so take a minute, pause the video, and see what you can come up with on your own. Okay, so for the first one, that's my easy one. That's always my given. The second one, it says that MT plus TH equals QS plus SP. Now what we're doing here is we're adding the same thing on both sides of an equation, and it looks really tricky. But here we said that TH was equal to SP. And the addition property, so let's say that TH was 5 and SP was 5. The addition property says we can add the same thing to both sides of the equation. Even though the TH doesn't look to be the same as SP, it is because we said up here that they were equal. So because we said they are the same thing, then we are in fact adding the same thing to both sides of the equal sign. Now the next one, this is going to be challenging. We just have that MH is equal to, so MH, looking at our picture, is equal to MT plus TH. Well, what did we say that was? When the whole segment was equal to the two parts. That's our segment addition. So we're just going to check to make sure this one's correct. QP, the whole length of QP, is made up of QS plus SP. That's our segment addition postulate. Okay? Now, this is where it gets tricky again. How does MH become QP? Well, up here, we said that MT plus TH equaled QS plus SP. So what I'm going to do here is I'm going to take this MH, I'm going to take this MH and replace it here. So MT plus TH is equal to MH. And we said QS plus SP was equal to QP. So I'm just replacing the MT plus TH here with MH. And I'm replacing the QS plus SP here with QP. So that is the substitution property.